Welcome to Solving One-Step Equations. After you're done watching the screencast, you should be able to solve one-step equations by using inverse operations. Before we start looking at solving equations, we need to consider some of the 10 commandments of math. Although we do joke, I do want to point out that commandment number 7 is really what we apply when solving equations. Thou shalt do unto one side of the equation what thou doest to the other. And really what that's saying is that an equation is like a scale. An equation is a statement that says that two quantities are equal. So for instance, if I put two emojis on one side of the scale, two emojis on the other side of the scale, I have balance. And equations need balance. So if I put an emoji on the right-hand side, I am out of balance. My equation does not balance. 2 does not equal to 3. So when I added 1 to the right-hand side, in order to balance, I have to add 1 to the left-hand side. And then we maintain balance. So in general, that means what you do to one side of the equation, you're going to do to the other side. When we're solving equations, we're going to have to think about the equation before we actually put pencil to paper. The 3 questions you want to ask yourself: what is the variable? What operation is being performed on the variable? And what is the inverse operation? An inverse operation, they undo each other. For instance, addition undoes subtraction. Division undoes multiplication. So addition and subtraction are inverses, multiplication and division are inverses. Let's take a look at our first example, going through our 3 steps. First question, what is the variable? Our variable is x. Next question, what operation is performed on the variable? Right now, we're adding 6 to x. What is the inverse operation of add 6? Subtract 6. So that's what I'm going to do to solve my equation. Subtract 6. Subtract 6 from the left-hand side, but what you do to one side, do to the other. So I will also subtract 6 from the right-hand side. As I look to combine my like terms on the left, x plus 6 minus 6 simplifies to x. On the right, 9 minus 6 simplifies to 3. So my solution is x equals 3. Now I know what you're thinking. I could have told you x was 3 without all of this work. But that's not solving. Let's take a look at the difference between find versus solve. For find x, those are different directions. Some of you might say here, there's x, I found x. But you probably know that's not what we meant. You might think, but I can show math. 10 minus 7 is 3. Therefore, x equals 10. And you might be correct. You found x. But that is not algebraically solving for x using inverse operations. This is not allowed. Anytime you see the directions solve for x, that means you're going to use algebraic operations and inverse operations. So to remind you, that means we're going to think about the problem before we solve it. What is the variable? The variable is x. What operation is performed on the variable? We're subtracting 7. What is the inverse operation of subtract 7? Add 7. So add 7 is how I'm going to solve for x. I'm going to add 7 to the left side of the equation and also to the right-hand side of the equation. When I combine my like terms on both sides, we get x equals 10. and that is how you algebraically solve for x. So as we compare the work, find x is not allowed in any algebra class. Solve for x is how you are expected to show your work. Let's try one more example. N over 4 equals 5. What is the variable? The variable is n. What operation is performed on the variable? This can be tricky. When we're looking at a fraction is another way of writing division. So the operation that's being performed on n, we're dividing by 4. How do we undo the divide by 4? What is the inverse operation? We're going to multiply by 4. So that third step tells me how I'm going to solve. So what I need to show is multiply by 4 on both sides of the equation. So n divided by 4 times 4 simplifies to n. 5 times 4 simplifies to 20. So n equals 20 is our answer. And this is the appropriate work to show when solving an equation. So again, our goal for the screencast was to solve one-step equations by using inverse operations. And I hope we've met that goal.